The function n equals n sub 0 times 1.5 to the t describes the actual number n of E. coli bacteria in an experiment after t time periods of 20 minutes each, starting with an initial bacteria count of n sub 0. A. What is the doubling time? Well, since we're given an exponential function, the doubling time remains constant, so an equivalent question would be, how long would it take for there to be 2 times the original number of bacteria? So our strategy will be to substitute 2 times n sub 0 for n and then solve for t. The first step in solving for t is to divide both sides by n sub 0. On the left side we get 2, and on the right side we get 1.5 to the t. Since t is an exponent, we can finish solving by taking the logarithm of both sides. I'm going to use a common logarithm. On the right side of the equation, we can use the property of logarithms that says that the logarithm of a power is the exponent of the power times the logarithm of the base. So the logarithm of 1.5 to the t will become t times the logarithm of 1.5. The last step is to divide both sides by the logarithm of 1.5. So t is the logarithm of 2 divided by the logarithm of 1.5. Using a calculator, we can evaluate the left-hand side, and it becomes approximately 1.71. So t is approximately 1.71. Now remember that each time period is 20 minutes, so this means that the doubling time is approximately 1.71 20-minute time periods. So if we take 1.71 and multiply by 20, that will give us our doubling time in minutes. So when we multiply 1.71 by 20, we get approximately 34 minutes. For part B, we're asked how long would it take for there to be 10 times the original number of bacteria? Well, this strategy is going to be exactly the same as for part A, except instead of substituting 2 times n sub 0 for n, we're going to substitute 10 times n sub 0 for n. So we use the same steps as we used in part A. First of all, we divide both sides by n sub 0. That gives us 10 is equal to 1.5 to the t. So next we take the logarithm of both sides and then use the properties of logarithms, and instead of getting log of 2 divided by the logarithm of 1.5, we'll end up with the log of 10 divided by the log of 1.5. Using a calculator, we find that t is approximately 5.68. When we multiply this by 20, we get approximately 114 minutes. So it will take approximately 114 minutes for there to be 10 times the original number of bacteria.